Good afternoon, everyone, and welcome to Cullen's Restraint Strap webinar. My name's Sam Kirkham, and I'm the Cullen Category Manager as part of ITW's Offsite Business Unit. And I'm pleased to introduce today's host. It's Mohib Javed. He is a product manager within the Cullen team and has been the key driving force behind the development of our restraint strap materials. So what is the purpose of today's webinar? So this webinar is to address knowledge gaps in the market concerning restraint straps. So this has been identified through our customer back innovation process. And what we've found is that these gaps span across various stages of the supply chain from design to on-site installation. So this session, being the webinar, is the first instalment of our 7-part internal straps campaign. And like the Cullen Gable Restraint webinar, our goal is to inform, engage and share best practices on restraint strap applications for roofs and floors. So what's Mo going to do? He's going to provide an overview of our restraint straps and their applications. And he'll be focusing on the what, why and how. And then we'll also follow this up by presenting some new and existing resources related to Cullen's restraint straps. After the presentation, we're going to have a Q&A session, and this will be with Scott McAndrew, our R&D Manager. And following that, we will do the PFS Scrap Bin Competition winner. In order to claim your prize, the participant with the closest answer must be present on the call. So Andrea will present that at the end. If you're not on the call, we'll go to the next closest participant in attendance. I also ask that you please hold your questions until the Q&A session. But there is also the Q&A button in the top left-hand corner if you want to use that, and we'll address them at the end. Also, finally, just ask that everyone puts their mic on mute until the Q&A session, and this is to prevent any background noise. So that's enough from me. I'll hand you over to Mo, who's going to take you through today's content.
Thank you, Sam. So hello, everyone. As Sam mentioned, I'm Mo, one of the product managers on the Cullen team, as you can see from that huge graphic on the screen. So yeah, like Sam said, the reason behind this webinar is that we've been putting a lot of effort behind the scenes to help close the knowledge gap around our restraint strap ranges. And we just wanted to share with all of you what's been done and why we've done it. Also, just before we get started, Andrea will be putting a link to the feedback form for this webinar in the chat. The feedback form link will also be at the end of the webinar, so don't worry too much if you don't click on it straight away. But the reason being is we'll cover quite a lot of content today, so feel free to jot down any thoughts and feedback as we go along. This feedback is going to help us create future webinars based on things you found useful and any areas we can improve. So we want to develop these sessions just so you'll get the best out of your time, and any input be very much appreciated. But yeah, like I said, don't worry. We'll also have a QR code at the end of the webinar, which you can scan as well. Right. Okay, so let's get started with the problem. So the why we are here. So we've noticed a bit of a restraint knowledge gap when it comes to our restraint straps. So whilst there are some educational materials available, we have found through market research from a lot of the insights coming from you guys that they are somewhat limited, which has left people unsure as to why straps are important, how to install them, and the right centers for them. Because of this, we are seeing a lot of mistakes, as you can all see on the screen. Straps either being installed incorrectly or not at all. Apologies if any of these are yours, but we all know that this leads to time-consuming and costly remedials, which none of us want. Our aim for today's webinar will be all around closing these gaps. So we're going to talk you through the why straps are required, the how to install them, and our new and existing materials to get strap installs right first time. Okay, so why are straps needed? Let's start by looking at the forces that act on buildings. So walls and roofs experience wind forces that vary depending on the wind's direction. For walls, these forces can manifest as either wind pressure or wind suction, and for roofs, we encounter uplift forces. When the wind blows, it creates a pushing effect against the walls, and as wind flows up and over the roof, it transitions into a pulling effect, leading to uplift. Think of if you've been camping before, if wind hits the side of your tent, as it flows over the top, it creates lift, which can, if you haven't staked your tent down properly, can cause the tent to pull up and start flying away. So hopefully no one's had any bad camping experiences recently, but this dynamic is crucial for understanding why straps are necessary. Next, let's look at regulations. So in traditional brick and block construction, wind forces must be restrained effectively and transferred into the floor and roof diaphragms as per UK and Ireland building regulations. So this is where restraint straps come into play. We provide our straps because they ensure that the required level of restraint to maintain the structural integrity of walls and roofs is provided as per regulations. Essentially, we need these straps to transfer wind forces into floor and roof diaphragms for brick and block structures. So our straps are compliant with approved document A for England and Wales, Scottish building standards, and the requirements set out by the NHBC and Home Bond. We're also currently working with the Irish government to get approvals for our straps as well, and we're hoping to have an answer on this in writing in the next few weeks. It is also worth noting that timber frame construction operates slightly differently. So engineers conduct design checks and timber frame manufacturers have their own methods for restraining walls and roofs. Whilst the underlying concept is similar, the specific details do differ. Okay, next, let's look at the centers that straps are installed at. Generally, for floors and roofs, the requirement for restraint straps is that they're to provide an 8 kilonewton tensile capacity and are to be installed at 2 meters max centers to comply with the standards set forth in approved document A and Scottish building regulations. So that 8 kilonewton value is particularly significant. We'll touch on that a bit more later on. But generally speaking, the maximum centers for floor and roof straps are 2 meters, as you can see in the diagrams on the screen. However, the requirements can vary on your location in the country and the height of your building. So in England and Wales, as per approved document A, for the first and second floors, restraint straps are installed at 2 meters max centers, and if there's a floor above, this spacing reduces to 1.25 meters. In Scotland, as per Scottish building standards, anything up to the first floor requires 2 meters max centers for restraint straps, whilst the second and third floors have a reduced spacing of 1.25 meters. So you can see here that centers reduce earlier in Scotland. One thing to note is that centers above the third floor are to be specified by the building designers, but effectively what this shows is that the level of restraint increases with height, and it emphasizes the importance of adhering to local regulations for structural safety. Right, so that covers the why. Let's move on to the what, namely our restraint strap ranges. Building off what we just discussed around the necessity of restraint, the following slides will focus on the products we offer and how they are installed. We produce a variety of straps designed for both floor and roof applications. Here you can see our different ranges, and I'm going to briefly touch on each one, but we're going to go into more depth for each range as we proceed. First of all, we have our two preformed strap ranges, our PS range and our PFS ranges. Our PS strap range is used to provide parallel restraint specifically for floor applications, and our PFS strap range provides lateral restraint for both floor and roof applications. Next, we have our twisted strap range, so the RST, which is designed for vertical restraint for roof elements. And lastly, we have our vertical restraint straps, which, as the name suggests, also provides vertical restraint and it is used for roof elements. I'll go into more detail on the specific applications in the upcoming slides, but the key takeaway is that all of our straps are accepted by both the NHBC and Home Bond and are compliant with approved document A and Scottish building regulations. This means that they can be used as alternatives to traditional straps in the UK, and later on in this webinar, we'll touch on engineered versus traditional straps. Okay, so let's move on to the applications for these, starting with parallel restraint of domestic floors. So our PS strap range prevent the movement of the walls by transferring external wind forces into the floor diaphragm. The straps are installed parallel to the joists, hence the name parallel restraint. So we have our PST strap, which is fixed in line with the top of the joist, our PSB strap, which is fixed in line with the bottom of the joist, and our PSC strap, which is fixed in line with the coursing of the blockwork when the joist protrudes above the coursing. Compared to our competitors, our straps are longer and have higher tensile values, meaning fewer straps and fixings are required per house. Also, the load values for our straps support floor opening details to meet NHBC requirements, and they support blockwork up to 250 mm wide, making them suitable for fire and party walls. In the diagram below, you can see the centers for the PST and PSC straps, which is essentially the same as what I stated in the general heights discussion. So that general 2 meters max centers with exceptions depending on height and location. However, the PSB strap is slightly different, as it is required generally either where joists have less than a 90 mm bearing on the wall, or where openings exceed 600 millimeters, for example, stairwell openings. But again, heights and location discussion still applies, so PSB straps are required at 2 meters max centers for the second floor and above for England, Scotland, and Wales. Okay, right, so that covers the overview. Now let's look at the specific applications in more detail. Just note for the PS range, whatever I say is going to be the same for both I-Joist and OpenWeb, and the next few slides will just be installation instructions, so it won't take too long to get through. We'll start with our PST application, PST with a non-restraint hanger. This is for restraining the walls to the top chord of a joist when the joist is level with the coursing. For example, using a 254 deep joist with a 250 deep hanger. So the installation instructions are pretty simple. Ensure the strap is tight against the blockwork and aligned with the top chord of the joist, and then fixed to the top chord using Pazzo square twist nails in every hole. Next, let's look at our PSC with a non-restraint hanger. This is also for restraining the walls to the top chord of a joist. However, here is where the top of the joist protrudes higher than the coursing level when using a hanger. For example, if you're using a 240 deep joist and a 225 deep hanger. Again, installation instructions are pretty similar. Ensure the strap is tight against the blockwork. Ensure it's fixed at the top flange, but here the strap is aligned with the coursing level and not the top of the joist. Lastly, we have our two PSB applications, starting with PSB Built In. So for this application, the PSB is used to restrain the walls to the bottom chord of the joist for a built-in detail. To install the strap, ensure that it's aligned with the bottom chord of the joist, tight against the blockwork, and then fix it to the timber, same as the previous applications. And next we have our PSB with a restraint hanger, which is pretty much identical to the previous application, except now a restraint hanger like an RA or a HRAD is used. The hanger provides additional restraint, so here the strap is only required when the spacing between the joists exceeds 600 mm, for example a stairwell opening, and not that 90 mm bearing of the joist onto the wall, as we previously discussed. But the strap installation is identical to previous. Align with the bottom chord of the joist, ensure the strap's tight against the blockwork, and fix it to the timber. Okay, so that's pretty much all of our applications for parallel restraint of floors. Next, we'll move on to perpendicular restraint of floors with our PFS straps. But just quickly, before we move on, I want to touch on these tables. So we have had some feedback on our PSC and PST straps that they're being used with the wrong size joists and hangers. So if there's ever any confusion on these, please refer to these tables in pages 139 of the Cullen Technical Guide to ensure that the correct straps are being used for whatever joist sizes and hanger sizes you're using. So the tables cover both I-Joist and metal web. So you can see I-Joist on the left and metal web on the right. And it has depth of hanger and depth of joist with the cross section telling you what strap you should use. So you get it right first time. Okay, so that's everything for the PS range. Let's move on to perpendicular restraints of floors. So our PFS straps restrain the walls to the floors by transferring external wind forces into the floor diaphragm. So this is the same as the PS range, except the straps are installed perpendicular to the joist, hence the name perpendicular restraint. Our PFS is an engineered strap, which is thinner than traditional straps, but it still achieves that 8 kilonewton tensile capacity, which means it can be used instead of traditional thicker straps. The PFS also provides a single solution for multiple floor and roof applications. And for the following applications, the strap must extend over a minimum of 3 joists. Below, you can see the different centers, which is, again, like the PS range, same as that general centers piece. So generally, the PFS straps are installed at 2 meters max centers, as shown below. But what we discussed on height and location still applies here for the PFS. Okay, let's move on to applications, starting with our surface fixed application. For perpendicular restraint, when the top of the joists are level with the coursing, PFS straps are surface fixed to the joists with noggins installed to provide additional fixing points. Before we get onto the strap install, I just wanted to briefly cover the installation of noggins. So this process will be pretty similar for both I-Joist and open web, but noggins are installed between the joists using 2 UZ clips and a skew nail per side. So the most important is that perimeter blocking. So without this blocking, there's still a gap in which the walls can move under wind pressure. So the straps will provide restraint against the suction forces that apply on the walls, and that perimeter block will transfer wind compression forces into the floor diaphragm. Also, just bear in mind when it comes to noggins, there are NHBC requirements for the timber. So noggins are to be at a minimum width of half the I-joist depth to a maximum width of 150 mil, a minimum depth of 38 mil, and a minimum of C16 grade timber. After all the noggins are installed, the strap can be located tight to the blockwork and centered on the noggins. You will nail the strap to the timber using Pazzo square twist nails, ensuring at least one nail goes into every joist. And on the next slide, you'll just be able to see a split screen of I-Joist and open web side by side. Okay, next, let's move on to PFS through the web of an I-Joist. So for perpendicular restraint, when the top of the joists are above the coursing level when using I-Joist, PFS straps must be installed through the I-Joist web. To do this, you will cut a small slot in each I-Joist web just underneath the top flange, slide the strap through the slot and position it tight against the blockwork. And just one thing to note is that you should not notch the joist top flange under any circumstances, as this is going to affect the structural integrity of the joists. Once the strap is in place, noggins are nailed in place between the I-joists, and same as before, the most important is that perimeter blocking. So once the noggins are installed, the strap is then fixed to the noggin using the square twist nails, and the NHBC requirements for noggins still apply here, except it'll be inverted for width and depth, because in the previous applications, noggins were installed horizontally, whereas here you can see that they are installed vertically. Okay, let's move on to the last application, which is PFS through the web of an open web joist. For perpendicular restraint, when additional noggins or strong back are installed through the metal web, PFS straps must be fixed to the additional noggins. So the additional noggins will be installed as per manufacturer guidelines. Then the strap is positioned tight against the blockwork and the noggins and will be fixed using the square twist nails. And yeah, I mean, that covers all of our floor applications. So let's move on to roof applications, starting with vertical restraint of roofs. Okay, so vertical restraint refers to measures taken to prevent the vertical movement or uplift of structural elements of the roof, namely wall plates and trusses. We have 2 straps for these applications. So we have our VRS straps and our RST straps. Both are engineered lighter weight straps that can be used instead of traditional straps, with the RST also having the added benefits of having higher load values compared to competitor solutions, and it has an engineered fold which allows for the straps to be fitted flat to both the masonry walls and the trusses simultaneously, which obviously ensures a secure connection. Below you can see the centers, so the VRS are required at 2 meter centers, which is pretty similar to what we discussed previously, with the RST being slightly different as it is only required on every truss specified by the building designers. If we look at applications, starting with the VRS on the left, the VRS provides restraint of the wall plate back to the walls to prevent uplift. To install the strap, you'll fix it to the wall plate using 2 square twist nails in the top, and then fixings into the masonry are to be specified by the building designers. The RST, on the other hand, is used to restrain trusses to the walls, and it is fixed to the trusses using square twist nails, and the nail quantity here is dependent on the uplift value. So if you want to find more information related to this, please refer to page 135 of the Cullen Technical Guide. Similar as the VRS, the masonry fixings are to be specified by the building designer. And if the RST protrudes over the top of the truss, like you can see in the diagram, wipe the strap over the top, as you can see on the image on the right. Okay, so that covers vertical restraints of roofs. Short and sweet. Let's move on to the last set of applications, which is horizontal restraint of roofs. So the PFS makes a comeback. For roofs, the PFS straps restrain the gable ends to the roof diaphragm, resisting horizontal wind forces. For the applications we're going to cover, the strap should be long enough to be fixed to a minimum of 3 trusses, with fixing points for the straps to be provided by either longitudinal bracing or noggins. If you want to find more information regarding fixing requirements for bracing and noggins, for bracing, please refer to PD Doc 6693-1. And for noggins, please refer to the TRA and NHBC guidelines. If we look at centers for these, it is pretty similar to what we talked about in the intro section. However, the wording will be slightly different as it relates to roofs. So in England and Wales, straps are required at 2 meters max centers up to including 3 stories, and then 1.25 meter centers up to 4 stories as per approved document A. And in Scotland, straps are required at 2 meter centers for anything up to and including 2 stories, and then 1.25 meter centers for above up to including 4 stories as per Scottish building regulations. Anything above 4 stories is to be specified by the building designers. And that is pretty much all on centers. So let's move on to the final set of applications. We'll start with PFS fixed to the truss web vertical joint. So here, the PFS restrains the diagonals of the truss when a bracing is fixed between the trusses. For this example, the truss bracing is in line with the blockworks vertical joint, hence the name truss web vertical joint, and the installation instructions are quite straightforward. So you'll fix the PFS to the bracing with a minimum with 8 25 by 4 mil steel screws, with those steel screws being an NHBC requirement. Ensure the strap bend is tight against the inner leaf of the blockwork, preferably located on the full block. And to accommodate the angle of the strap, ensure that the blocks are notched and the notches are fully mortared. One thing to note for these, for the remaining applications, is that the blockwork is to be built up to suit the strap location and not the other way around. Next, let's look at PFS fixed to the truss web in line with a horizontal blockwork joint. Okay, so this is pretty much the same as before, but here the PFS is in line with a horizontal blockwork joint and not a vertical one. One thing to note is that here, if the position of where the strap should be doesn't coincide with an existing longitudinal truss brace, then the strap may be fixed to an additional longitudinal binder. But for the strap install, same as before. So install the strap using the 8 steel screws. Ensure that the bend of the strap is tight against the blockwork, preferably on a substantial piece of blockwork, and notch the blocks to accommodate the angle of the strap and ensure all notches are fully mortared. Okay, next, let's move on to PFS fixed to solid noggins. Here, the PFS restrains the diagonals of the truss when noggins are used between the trusses. Noggins are to be fixed horizontally to avoid the twisting of the restraint straps, and the straps are to be fixed to the noggins with 8 Pasload square twist nails, with 2 fixings into that 4th noggin, so the one that's just past the 3rd rafter. Same as before, the bend of the strap is to be held tight against the inner leaf of the blockwork, preferably located on a substantial piece of blockwork, and if needed, notch the blocks to accommodate the angle of the strap and ensure the notches are fully mortared. Okay, let's look at the final application, which is PFS fixed to truss ceiling. Here, the PFS restrains the gable ends when the truss bracing is in line with the bottom chord of the truss. Like the first and second applications, the PFS is to be fixed using 8 steel screws and ensure the bend of the strap is tight against the blockwork, preferably on a substantial piece of blockwork. One thing to note for this application, if the position of the longitudinal bracing does not coincide with a horizontal blockwork joint, then a cut block can be inserted to suit the strap location as shown in the diagram. Okay, so that is all of our individual strap applications. However, for those who might not be aware, we also have a system for timber gable end restraint, which combines our straps. So for those of you who may not have been on the last webinar, or even if you were, just a quick refresher, our restraint straps combine to form Cullen's Gable Restraint System, so our GRS, which is designed to prevent gable end collapse for timber gables. You can see in the diagrams the different parts and centers, and if you want to find out more information related to this, please refer to our YouTube channel, which has our installation videos as well as the previous webinar. We have our online GRS tech guide, and we also have information related to this in our existing Cullen technical guide as well. Right, so let's come back to traditional versus engineered straps. Okay, so going back quite a few years, the original standards which covered straps had heavy duty straps to be 30 by 5mm and light duty straps to be 30 by 2.5mm. Then there was the introduction of the BSEN 845-1 document, which allowed for innovation around straps, and these standards were changed. So previously, there wasn't a test requirement for heavy duty straps, just that size and thickness you can read above. Below. But then we had to test heavy duty straps. Once this was done, it was declared that straps had to achieve an 8 kilonewton tensile capacity. So I appreciate it's quite small on the screen, but if you look in the bottom left of the screen underneath engineered, there's a section which says to provide an equivalent performance to the prescriptive 30 by 5mm lateral restraint straps commonly used in the UK. Tension straps should have a declared load capacity of no less than 8 kilonewtons and a displacement of no more than 2 millimeters. So for the UK, it was straps either had to be 30 by 5mm, or if not, they had to achieve that 8 kilonewton tensile capacity, but not both. So provided that straps achieved that 8 kilonewton value, they were compliant with regulations, which obviously makes sense nowadays because 30 by 5mm straps don't exist anymore. And as a result, we focused all of our efforts on engineered straps. So all the straps we covered today are accepted in the UK and are compliant with approved document A, Scottish building regulations, and we have approvals with the NHBC for all of them. However, the issue with Ireland that we are currently testing is that we don't have this annex. So in Ireland, it states that straps have to be 30 by 5 mil and achieve that 8 kilonewton, not the or like in the UK. But this is obviously somewhat outdated as the 30 by 5 mil straps don't exist. But because of this standard in writing, questions have been raised around the use of engineered straps in Ireland. Currently, we are having positive discussions with the Department of Environment in Ireland to get the standards around these changed. Hopefully, we will have something to show for this in writing in the next few weeks. And we've also recently had acceptance with Home Bond, which is showing steps in the right direction to hopefully clear up any questions around engineered straps in Ireland. Okay, so that is pretty much all of the content for today. Before I hand back over, we'll just do a little bit of housekeeping. So I have mentioned this throughout the webinar, but just to reiterate, blockwork fixings, floor restraint for the 3rd floor and above, and roof restraint above 4 stories are all to be specified by the building designers. And we also have some brand new resources we would like to make you all aware of. So we have our Q3 update of the Cullen Technical Guide, which has recently released. We have a new Straps Technical Guide, which is scheduled to release in some point in the next few weeks. And the big one is that we have new installation videos, which are going to be in the same format as this webinar. So parallel and perpendicular restraint for floors and vertical and horizontal restraint in roofs. So I know some of you might be thinking these videos are going to be fairly long, and they will be, but what we've done is we've added timestamps for each application along with QR codes linked to those sections, making them easy to navigate. Our end goal is to have these QR codes on drawings. So say, for example, someone on site is installing PFS surface fixed to Noggins. They can simply scan the QR code on the drawing, jump straight to that section of the perpendicular restraining floors video, and get clear guidance on how to install the strap correctly first time. This sort of leads nicely onto my next point. So we have a QR code pack, which we can send out and is make available on our technical portal, so that is easy for you all to access. So yeah, again, the QR codes will link to our videos and online resources with the aims of them being on drawings that are sent out to site. Our offsite technical portal will also contain this webinar video, and I'm sure this is also going to go on our YouTube channel. And we also have 3D part drawings if you need. And the last bit of new content is we're currently developing a straps e-learning module. So this should be released either later on in Q4 or Q1 2025. And it is going to be an interactive way to cover content and learn about our straps. Think of it like an interactive version of this webinar in many respects. And I'm sure all of you are aware, but we also have our offsite technical support team and our offsite customer services team who are available to help with any queries that you guys may have. Before I hand back over to Sam, I'd just like to share one of these videos that we created as part of the educational package. And yeah, this is a webinar exclusive release. So you're the first people that are going to see this video. Okay, so like I said, we'll have 4 videos covering all of the floor and roof restraint applications we've covered today, which will mainly be targeted for the on-site installers. And yeah, while the videos are lengthy, we will provide timestamps for the specific applications and QR codes to make those timestamps easy to navigate. And this is the first release of, well, this is the first one of the videos. The rest of the videos will be released over the coming weeks. Okay, so that is it from me. Thank you, everyone. Really appreciate your time. I'll hand back over to Sam and Scott.
Thanks, Mo. So we'll get the Q&A session kicked off. And Scott, I'll open with the first question before opening up to the floor. So this is a 2-part question based on the use of a restraint strap. So what type of remedials do you see coming through? And what is the most common design gap you see when analysing designs?
Probably the most common remedial is the fact is the strap's not been installed, and then asking if a strap could be retrofitted, which can be done, but it's no straightforward, it's no simple. These straps are taking an 8 kilonewton capacity, 2 metre centres. When you're trying to retrofit it, you've got to face fix it to the blockwork, which is usually aircrete blocks, which fixing into them is pretty rubbish. So your 8 kilonewtons, you're not going to achieve that, and we'll end up trying to achieve the equivalent of like 2.4 kilonewtons, which is the straps being installed on every joist or at 600 centres, and that is just achievable. At the moment, we're looking at different fixing options and trying to see if we could improve that, but that is probably the most common issue, them not actually being installed in the first place. And the second part, probably the requirement around openings for where straps should actually be installed. Where do you need to go and install the straps when you've got openings in buildings? And where do you start the straps from like the corner, from the corners, or do you come in the 2 metres? So the corner acts as a restraint, so you start your straps 2 metre for the corners. But then when you've got openings, anything greater than 600, you should actually be installing straps on them if it's a built-in detail. And you should put hay straps either side of stairwell opening, because your stairwell opening is always going to be greater than 2 metres.
All right, thanks, Scott. Okay, so just open up to the floor. Is there any questions? Anyone got anything to ask Scott related to our restraints straps? Okay, Daniel Backley, if you want to unmute and go for it.
Afternoon. Hi, Scott.
Hi, Daniel.
All right. It was just a question on the PFS. For particular use, your manual indicates that it needs to go over a minimum of 3 joists, which if your joists are 600 centres is fine. If your joists are, say, ridiculously 100 mil centres, is that suitable? Or is there a minimum length that the fixings need to be going over to get the fixings into the noggins, etc.?
If your joists were at 400 centres, then it still have to go over your 3 joists. So it is just to get it into that floor diaphragm. Are you going to put joists less than 300 centres because you're going to struggle to get into nail them? As the fact is, you're just trying to get the restraint further back into that floor diaphragm, but the floor is going to be screwed and glued. So it is just getting it into that floor diaphragm. That's all you're trying to do.
Yeah, it's just in the modern age where builders are trying to reduce the costs anywhere where they can, and if they can have less restrap noggins and Z clips for straps, because going by the letter of the book, they only need to go over 3 joists. If you've got some argue that you got a 2-ply joist and a joist against the wall, well, that's already 3 joists. I don't need to go any further. You get weird and wacky nonsense like that. It's just trying to get a bit of clarification on that. Us as I-Joist manufacturer, the strap is 1500 long. We want noggins over the whole lot.
Yeah. Well, I'd say your strap should be covering kind of rule of thumb coming 1200, at least covering 1200 into the depth of the floor. But that's something I could possibly go and look at and go and ask for further clarification on. But we're kind of, it does state like into your third joist. That's coming from like the NHBC standards, and it's in the building, the approved documents as well. So
cool.
But fair point.
Thanks, Daniel. Okay,
Cheers.
is any other questions out there?
I've got one I'll ask, please, Sam.
Go for it, Philippa.
So, are there any specific considerations for integrating restraint straps with HVAC, plumbing, or electrical systems in buildings?
I need to think about that. I don't think they would affect them because most of the straps run along the flanger joist or along the top of the underneath the floor deck. So these systems shouldn't affect the strap positions, and there shouldn't be requirements for additional straps. I think it'd have to get done on a case-by-case basis, but the strap positions shouldn't be affected by any of these new future requirements for different services within the floors.
All right. Thanks,
you.
Philippa. Thanks, Scott. Scott, I've got one in the chat for you as well. So this is from Glenn Watson. The PFS through the metal web joist is shown fixed to the top cord. Can this also be fixed to the bottom cord if the coursing suits better?
The PFS through the
metal web joist is shown fixed to the top cord. Can this also be fixed to the bottom cord if the coursing suits better?
You want to try and get that strap as high up the joist as you can, because that's where your floor deck is, that's where your diaphragm is. If you were to fix it to the bottom, then I've never been asked about this for metal web. If you were to do it to the bottom on an I-Joist, you'd have to go and put like a full depth I-Joist noggin in between. I'm not quite sure regarding that, if it was a metal web and you're trying to get it onto the bottom. I'll have a look at that one.
Right, Glenn, any follow-up question, or does that answer what you're needing? Okay. Okay, I'll open back up the floor. Is there any more questions out there?
I've got a question for you, Scott. Do you know if there's any recent updates in building regulations that are going to impact the use of restraint straps?
At the moment, there's no changes to the building regulations for Scotland or England. It's going to change the straps, and I've recently just had a look through the NHBC 2025 standards, and there's no changes to the strap requirements. There's no additional requirements or anything. So at the moment, all is good, and everything that we've just done in the webinar should be compliant.
Okay, lovely. Thank you.
Thanks, Jordan. Any more questions out there? No? All good? Okay, well, close out the Q&A session there. Thanks for everyone's questions and engagement. We're going to jump over to the prize. Oh, wait now, I've just had one come through. Sorry, Scott. I'm going to rewind. Okay, so Scott, I've got a question here from Richard Green. If you have joist parallel to the external wall with an SVP opening, then there are two joist trimmers to allow for the SVP opening. Does this provide any restraint?
So if you've got a joist parallel to the wall, you've got an SVP trimming.
Yeah, so if you oh, sorry.
So,
can you reread it?
Aye, go and reread it.
Sorry, I'll reread that. Okay. If you have a joist parallel to the external wall with an
Yeah.
SVP opening, then there are 2 joist trimmers to allow for the SVP opening. Does this provide any restraint?
That is going to provide the retrimming joist is going to provide the equivalent of your blocking piece at the end, but it's no providing restraint against the tension forces. So you still got to put your strap. You still have to put your straps in to take the wind force, the wind tension force. The straps. What the straps are mainly doing is when you've got the wall and the wind pressures on the wall trying to take it in the floor diaphragm, the wind force being blown onto the wall. It's through the blocking and the noggins and the floor. It takes it into the floor diaphragm, the decking. When it's pulling, that's where the strap's needed. So when you've got that tension force, it's pulling the block work away, and that's when the strap's required. So although you've got the SVP and it's no, and if you're talking about it being sitting on hangers or being built in, it's not going to provide the equivalent of your 8 kilonewtons at your 2 meter centres. You'd have to have it built in all the way along the wall, or you'd put the straps in at 2 meters. So it's no giving you the tension restraint. So no, you still have to put straps in.
All right, thanks, Scott. Richard, does that answer your question? If you've got a follow-up question, if not, we'll move on. Nope. Okay, yeah. Okay, so we'll move on to the prize. Oh wait, sorry, I've got another one. Go back again. Final one, I promise. This is Paul from Paul and Nikki from. So Paul is asking, what is the process with PSC straps at staircase with the flange going into the opening? ITW need to give a useful handed version.
Kent, that was coming. At the moment, it is something we're looking at. The only advice I would give is on that one strap where it's going to clash with the noggin. On the one strap at the noggin where it clashes, I would move that back to beyond the bend on the strap. That's the only advice that we could give at the moment. But it is something we know about and we're looking at.
Okay, cheers, Scott. Cheers, Paul. Now I've got another one. Last one that just came in through Amy Stevens. So, should the restraint strap centre start from the ridge, and should they be either side of the ridge of the truss?
No, you could take the ridge as being the restraint strap. So that's your. If you've put in, you'd probably have one brace along the centre. You'd have your restraint strap at the centre. So then from that you'll go 2 meters that way, 2 meters that way. So it's you didn't put two straps at the ridge. You can if you want. Helps my bonus. But you start at the ridge and you go 2 meters down and 2 meters down. Or if you're starting at the eaves and working your way up, depending on where you get to, that's how you'd go and do it that way.
All right. Thanks, Amy, for the question, and thanks, Scott. Okay, so we'll close the Q&A session now because we're getting tight for time. We'll jump on to the prize section, so third time lucky this time. So I'll hand you over to Andrea, who's going to take us through this.
Now for the very much awaited moment for the prize draw for today. Now, first of all, I want to announce what the weight indeed was. And we're going to come at 95 kilograms, straight on. Now, I've got a list of people here, and the closest person, and if they're on the call, they're the lucky winner, is Matthew Bolton from Crendon, with a lucky guess of 94.2 kilograms. Matthew, we'll be in touch with you for your lucky prize for the £150 Amazon vouchers. And thank you all for participating and taking part into our competition.
Okay, thanks, Andrea, and well done, Matthew. Just in time for our Black Friday sales, so enjoy. Okay, so I'm just going to do a little bit before closing out. So before closing, I just wanted to take a moment to thank the ITW team for their hard work and dedication. There's a lot of time and effort, blood, sweat and tears that's went in creating the content for the Restraints campaign. So Your efforts are greatly appreciated, and a big well done to everyone involved. Also, if you have any further questions regarding our restraint straps, or you want any more information that we've maybe not posted, please don't hesitate to reach out. So you can reach out to any of our commercial teams that are on the screen at the moment. We also have our 2 service functions and support lines that Mo mentioned earlier on, also on the bottom of the screen. Or feel free to reach out to one of the Cullen team that have been taking lead on this webinar as well. Lastly, I'd like to also thank you all for joining today's session, and I would also like to extend my gratitude to our customers who contributed with valuable feedback through our customer back innovation process that I stated at the start. Without the input that you guys have put towards us, we wouldn't have been able to shape our initiatives or drive progress regarding our restraint straps. So really is appreciated. Also, as Mo mentioned, we've got a short survey, so we're looking to get some feedback from you guys. At Cullen, we're always committed to continuous improvement, so you can access this by scanning the QR code that's on the screen. Also, if you don't have time to do it at the moment, bear in mind I know there's only a couple of minutes left before 2 o'clock. We'll send a follow-up email where you can fill in this feedback form as well. And with that, that concludes today's session, and I'd just like to say thank you once again for being here and giving up your time. Have a wonderful day. Cheers, everyone.